Hello, ladies and gentlemen. My name is Joseph Mogul. I am an alumni of Clark University. Uh, I graduated December 2020. My major was in military history with minor in geography. I also have associate degrees in electromechanical engineering and biomedical engineering from Quinsigamond Community College and have previously worked as a civil electrical engineer. I also have been an amateur blacksmith and bladesmith for quite a while now. I'm here to talk to you about African metalwork. Now, metalwork, in general, breaks down into two key categories. You have forging, which is heating up a metal and smashing it with a hammer to change its shape. And you have casting, which is heating up a metal to a liquid point and then pouring it into some type of a mold or form that the metal cools in. There's a difference to the crystalline patterns. Forging tends to be a lot stronger than casting. Casting is more apt to snap, it's more brittle. But casting also results in much finer initial details, whereas forging always tends to be rough and requires what's called finishing work. So all metalwork starts with the metal, and all metals come from what's called ore, O-R-E. Now these are stones that contain the metal ions, the individual atoms of the metal contained within the overall stone. The process of getting the ore out of the stone is called smelting. Smelting takes place in a very specific type of furnace called a bloomery. It's called a bloomery because the metal that comes out at the end is called the bloom. So you put your stones, your ore, into the furnace, the bloomery furnace, and then you heat it up. You heat it up with something called coke, C-O-K-E, not like Coca-Cola. Coke is a very fine, high-grade carbon fuel. Now it's usually some type of either dug out of the earth coal or charcoal. Now in Central Africa, with all the various types of wonderful hardwood trees, you can make some incredibly fine high carbon coke. This is done by burning the wood in what's called a low oxygen environment. It's usually a big pit that the wood is burned in while it's covered over with a lot of dirt and a tiny little hole to let a little bit of air in and out. The reason that you use coke, this very high carbon material, is very specific. The excess carbon ions that burn off in the process of burning the coke will bind to the non-metallic particles that are coming out of the stone. So while your iron, your copper, your tin, your zinc, whatever else is coming out in liquid form, the carbon ions are binding to the potassium, the phosphorus, the sulfur, the other stuff that you don't want mixing in with the metal. The finer the coke, the better the metal is that comes out at the end. If you don't have a very high quality coke, you wind up with what are called inclusions. Now the term inclusion is used in a few different places in metalwork, but in smelting it refers to tiny little pockets of either gas or minerals that get included in with the rest of the metal. So Central Africa was blessed with not only excellent iron reserves, there's a lot of what are called open pit iron ore mines. In other words, the iron ore is literally just sprinkled on the surface of the ground. But also has these marvelous hardwood trees that can produce beautiful high quality coke to smelt excellent quality iron. Alright, that's smelting. That's stage one. It's usually, most often you're going to hear it in reference to iron, but you have to smelt any type of metal. This includes copper, which I'll be getting to in a couple of minutes. Next we come to forging, area that I'm very familiar with. Forging is done with basically four primary instruments: the forge, the anvil, hammers, plural, and tongs, plural. The forge is the fire that allows you to heat up the metal so that it's a malleable temperature. The metal needs to be hot enough to smush and bend and twist and shape, and that's done with the hammers, the anvil, and held in place with the tongs. Now a forge, unlike a furnace, which is used in casting and the bloomery furnace in smelting, does not get the metal to liquid level. You don't want liquid metal. You just want it hot enough to smush. To get an idea of the consistency of what metal at about a yellow-orange heat would be, take a piece of Play-Doh, put it in the freezer for a couple hours, take it out and smush it around. Guess what? That's kind of what a yellow-orange temperature, a yellow-orange glow iron feels like when you're hitting it with a hammer. It smushes just a little bit. Now the process of using different hammers, and you use different hammers because different shapes to the hammer move the metal in different ways. Again, you can use that frozen Play-Doh and test this out for yourself without having to worry about burning your house down. Now, you also have different types of tongs, and this is just to hold different types of metal. And when I say different types, it's not like one set of tongs for copper, one set for iron, but rather it has to do with the shape the metal is in initially. See, after the metal comes out of the bloomery, it's forged down into what are called billets. And all a billet is a specific regular geometric shape that allows you to store the metal easily. It could be something that hangs on a wall, or it could be like a big brick shape that you just stack up somewhere. That's all it is. A billet is just a shape that makes it easy to store the metal. So you take your billet, use a set of tongs that grips that billet optimally, you heat it up in the forge, and you hammer it on the anvil. Now, in Africa, unlike most of Eurasia, the standard posture for the smith is actually a squatting position, sitting down with both feet firmly planted on the ground, and the anvil usually stuck with a spike of some kind deep into the ground. This makes it easy to actually pull the anvil out and move it somewhere else. It's a more mobile setup. Whereas in Eurasia, most of the type of smithing setups involve an anvil that's usually at about waist level. There's a reference to like knuckle height as the ideal level for an anvil in most Western and Eurasian styles of smithing. But in Africa, it's done in a sitting position. And I could go and I could spend an hour talking about the different techniques and methodologies, hammer types of tongs, the shapes of the anvils. All of these things play a part in how the metal is moved once it's heated up. But fundamentally, it comes down to you heat the metal up, you grip it with the tongs, you hit it with the hammer against the anvil, and that gives you your shape. Now, Africa has one other interesting little thing with hammers and anvils, in that there are stone anvils and hammers. The reason for this is while stone is more brittle and less durable than iron or steel for hammers and anvils, it's less thermically malleable. Right? The stone doesn't pull heat out of the metal that you're forging the way that iron does. So you have a much longer time period to work with that hot metal before you have to put it back into the forge and heat it back up. That saves you on coke, which means, or that saves you on charcoal, which gives you a little more time to actually get your forging done. Okay, like I said, I could talk about forging for another hour or two, but I'm only going to be here for a few minutes to give you this little overview. The next thing, casting. Casting is done by taking your billets, your chunks of metal, and putting it into what's called a crucible. This is usually stone because it holds its heat very well. It's thermically very insulating. A stone bowl with a little spout on it. This is heated up in a furnace until it's red hot. You put your billets in and you heat them up until they literally melt. This is why you don't have a lot of cast iron. Iron's melting temperature, its liquefaction temperature, is 1500 degrees centigrade. That is 1/4 the surface temperature of the sun. That is very, very hot. Copper has a lower temperature. It's a couple hundred degrees cooler. So you liquefy it, you pour it into a mold. There are a few different types of molds. You have sand casting, which is where you make your mold in wet sand with something inside the sand to create the shape. You also have casting that's done using what's called a lost wax mold, which is where you make a shape in wax. You coat that in plaster. Once the plaster hardens, you heat it up to melt out the wax. It's important that you melt the wax out entirely. And that's because if there's any wax in there, once the liquid metal heats it, it will immediately vaporize. When that wax vaporizes, you have a bomb with liquid metal inside of it. So, very crucial that you melt all the wax out and you pour your metal in. This brings us to the metal itself. The most common type of metal that is cast is copper. It's easy to cast. Anyone can do it. Tin is also pretty common. For people who do this stuff at home, usually melting down aluminum cans. Aluminum is also very easy. Aluminum cans can very easily be cast at home. But the pinnacle of casting is done with bronze. Bronze is an alloy. Most types of casting are forms of alloys. The issue with an alloy is you have to get the ratios of the metal just right, and because the metals don't have the exact same melting temperature, controlling the temperature is crucial. So when you look at those Benin bronzes, keep in mind, those smiths, those casting experts were able to get exactly the right ratio of copper to tin at exactly the right temperature in a mold that had all the materials removed from it, so you had exactly the right cast. Now, if you don't get exactly the right ratio of metals, you don't get exactly the right temperature, it can be a problem. Brass is a prime example of this. Brass is an alloy of mostly copper and a little bit of zinc. The The problem with zinc is zinc produces something called zinc oxide. Zinc oxide is toxic and produces what's called forge fever. It can make you very sick. I've had forge fever. It is not fun. So when you look at these cast works from Africa in bronze and in brass, keep in mind, these masters of their craft knew how to get exactly the right ratio, at exactly the right temperature, without getting sick, and had a mold prepared exactly as needed to get exactly the cast they were looking for. Keep that in mind, folks. All right, you be good. Take care.